Hello pre-calculus students, and welcome to a video on even and odd functions. So the goal for this video is to determine whether functions are even, odd, or neither, either from looking at a graph or from looking at an equation. Okay, so let's start out with defining what we mean by even and odd function. So first of all, for every x in the domain, negative x has to also be in the domain. And for an even function, f of negative x must equal f of x for all x. Okay, for all x in the domain. All right, and this is symmetry with respect to the y-axis. And you're looking at an example of an even function right here. You probably recognize this as y equals x squared. Notice that what we have is whatever f of x is, f of negative x is the same thing. So for example, if x is 1, the output is 1. Same thing, same output for x is negative 1. If x is 2, the output is 4, and it's the same output for the opposite of x. So every time we have opposite inputs, we get the same output. And that's another way of saying this. So we can say also that opposite inputs give the same output. Okay, let's look at odd function definition. So for every x in the domain, negative x is also in the domain, and f of negative x is equal to the opposite of f of x. This will give us origin or rotational symmetry around the origin. We just call this origin symmetry. Here, opposite inputs give, well, instead of up here where it was the same output, here you're going to get opposite outputs. What do I mean by that? I mean, if your input is positive 1, your output is positive 1. But with the opposite input, like negative 1, the output will also be opposite. So here, if you have 2, 8, that means it's also going to have negative 2, negative 8. And that's the property of an odd function. Okay, here, if it has 2, 4, it's also going to have negative 2, 4. The opposite inputs give the same output. Here, opposite inputs give opposite outputs. Okay. So these little graphical aids, if this were on the coordinate plane and right about, I think right about here, were was the origin, then this would be a rotation around the origin. So that would be an odd function. If this were, this could be the y-axis, and the x-axis could actually be anywhere, and that would still be an even function. The odd function is a little bit more specific, can't be moved up or down. All right, let's look at a couple of graphs and just make a decision whether they're even, odd, or neither. Okay, so if you're looking at reflection over the y-axis, like this first one, this would be an even function. This is just to point out what I just said about this here, is that if it's moved up a little bit, it might have rotational symmetry, but the center of rotation is not the origin. This would be neither even nor odd. And this last one does have a rotational symmetry around the origin. If there was a point, whatever here, let's say that this is like 2, positive 2, then there's a negative 2, negative 2 right there. There's always going to be the opposite outputs giving opposite inputs giving opposite outputs. That makes this one odd. Okay, it's usually pretty easy to tell if you see the symmetry looking at a graph. Just have to remember that if it's moved up or moved down, that is not symmetry. That's not the kind of symmetry that we're talking about. Okay, so let's look at a couple of examples of determining from an equation whether the function is going to be even, odd, or neither. Now, I chose this first example because I wanted to dispel a myth that some students have asked me over the years of whether this certain test will work. let's do the test the way that we're going to do the test. We'll do it the right way, and then we'll look at how the wrong test gives a false answer. Okay, so we're always going to look at f of negative x. That's for sure. That's a given. In this case, you would get negative x. You're going to replace all your x's with negative x minus negative x plus 1. All right, now whenever you are raising a negative to an odd power, you think of multiplying negative 1 by itself an odd number of times. You're going to end up with a negative number. So this would be negative x to the third, or the opposite of x to the third. This is just subtracting a negative, so that's plus x, and that's plus 1. Now, we have to be able to look at the function that we found for f of negative x. And the hard part is not actually finding it. The hard part sometimes is deciding, is this the same as what we started with? Is there some way that I could tweak this that it would actually be the same exact function? And there's no way. And usually what you need to look for is, can you multiply it by negative 1? And if you multiply this by negative 1, the first two terms would actually match up, but the last term would become negative here, and it still wouldn't match up. All right? And sometimes you need to ask yourself, am I sure that this is not the same thing as the opposite of negative x? So you make sure you know what the opposite of f of x is, to make sure that these aren't the same, because if this is the same as this, that's the definition of an odd function. In this case, we would get negative x cubed plus x minus 1, and it's off by this one right here. The 1 really ruins this one for being positive or negative, and that's kind of because it's a vertical translation is related to that negative 1. All right, here's the wrong way to test this. So this is the result here is that this is neither even nor odd. Now here's the wrong test. So here's a bad test that some students in past years have used. I don't know if you guys got it from a teacher or you got it from other students. That is to say, let's just try 1 and negative 1. So if you try f of 1 and f of negative 1, see what you get. So if you try 1, you get 1 cubed minus 1 plus 1. That is 1 minus 1 is 0 plus 1 is 1. If you plug in this one, you get negative 1 cubed, and then subtract a negative 1 plus 1, and this gives negative 1, this gives positive 1, so they cancel, and this also gives 1. So you say, oh wow, look at that. F of x is the same thing as f of negative x, so this must be an even function. So you say it's even. And I say, don't do that. Okay, that's not right. Okay, let's move on. That test just doesn't work. Okay, it's got to be x in there. It's got to work for all numbers. So just having it work for one number doesn't really determine whether it's even or odd. Okay, let's look at the next example. I'm going to ask you to pause the video and actually try B and C and see if you come up with the right answer for the test. The even-odd test. Okay, so if we look at example B, we see with a little bit of work, we can actually take, this is the cube root, so we can actually take the cube root out, and the cube root of negative 1 is negative 1, so it just comes out as a negative. And so what we actually have here is the opposite of what we started with, so it turns out that f of negative x is the same thing as the opposite of f of x, which is the definition of an odd function. Okay, I'm going to pause the video and let's try C. So I left this one incomplete because sometimes, and I wanted to make the point that sometimes you look at a function and, okay, you look at this compared to this, you look at f of x compared to f of negative x and say, okay, they're definitely different because this one has a negative, this one has a positive. Sometimes you're just not quite sure if it's the same as the opposite of f of x. So in that case, you need to take that other step and find the opposite of f of x. Because remember, if these two things are the same, then you have an odd function. So let's take the opposite of f of x, which is putting a negative sign in front of the whole thing. And remember that when you have a negative sign in front of a fraction, you can put it in the numerator or the denominator. We'll put it in front of the numerator, because then it is exactly the same thing. So now we see that f of negative x is the same thing as negative f of x, and that makes this also an odd function. Okay, let's look at absolute value. So we have f of negative x. And, if you want to pause the video, you can, just to see if you get it right. But when we take the absolute value of negative x plus 4, it's important to think about the absolute value just a little bit here and realize that the absolute value of negative x is always going to be the same thing as the absolute value of x, no matter what your input is. Whether this is a positive or negative number, the opposite of it will still be the same number as far as the absolute value. It's just going to be always the positive version once you take the absolute value. So this is the same thing as the absolute value of x plus 4, and that makes this the same as f of x. So this is an even function. All right, let's look at one that's similar but just a little bit different. Here, if we take f of negative x, absolute value of negative x plus 4, and this one is different because now it's different because it depends on whether this number, well, we can think of some inputs that would make these two things different, right? They're not always the same. No matter how hard you try over on this one, you think of an input like negative 1. You're just going to get 1 plus 4 is 5. If you think of it in this case or in this case, negative 1 would become a positive 1, and it's still 1 plus 4 is 5. And there's no numbers that you can't do that with. Here, if you make x negative 1, what happens? Well, in this case, if you make x negative 1, you're going to get 3, right? Negative 1 plus 4 is absolute value of 3, which is 3. Here, if you make this negative 1, you have the opposite of negative 1, which would be 1, and this would be 5. So they're not always going to be the same. So this is different, and this is going to be a neither. Okay, so one way to think of this is like an f of x plus h. So this actually moves over like here. Something like that. Okay, so it's moved over. It's either to the left or to the right, but it's definitely not to the y-axis. Okay, let's look at one more here. So why don't you guys take a minute and see what you get for this one. So I'm going to pause the video, see if you can get, actually f and g are very similar to each other, so I want to keep this under 15 minutes, so why don't we try f and g, and I'll just tell you right now, one of them is neither and the other one is either even or odd. Okay, so here's what we get for f of negative x for each one of these once we take care of the taking the odd power. Remember, whenever you have an odd power, that's going to be a negative, so this is the opposite of that negative, so it's still the opposite in front of there. And now it's the opposite of negative, so that turns into a positive because the negative comes out. Okay, and then these stay negative. All right, so one way of trying, you really want to be able to tell whether either one of these is either the same as f of x or the same thing as the opposite of f of x. So one thing you can do to see if it's the same as either one of those is you can multiply this by negative 1 over negative 1 and see what happens. If we multiply this by negative 1 over negative 1, it pretty much changes the sign of every single term. So it would become negative 1 minus x to the 7 over positive x plus x to the 3rd. And that still doesn't quite fit. Like the pluses and minuses are never quite matching. Okay, so this is definitely not f of x. We can still look to see if it's odd in a second. But let's do the same thing over here. Let's multiply this by negative 1 over negative 1, which again just changes the sign of every single term. So this time we get negative x to the 7 over positive x plus x to the 3rd, and that is exactly the same thing as f of x. So yeah, as we can see here, f of x, f of negative x is the same thing that we started with f of x, so they're the same. We can also go back and look at this one, and we can do what I did here, which is find negative f of x, just to make sure that we've established that this is not even, but just to make sure that it's also not odd, and this will never give you the same thing as f of x or f of negative x. The pluses and minuses will never quite match up.